In this video, we'll go through the typical evolution of a Terraform project. We start with a small personal project or maybe a startup and gradually evolve it into large-scale enterprise Terraform deployments. When you're just getting started, you may create a separate Git repository, for example called infra, and start putting all your Terraform files there. In the main.tf file, you might initialize Terraform provider and define components like AWS VPC. For simplicity, let's say you deploy your app using EC2 instances. As time goes by, you'll learn some Terraform naming conventions and decide to refactor. You place the Terraform provider in its own file. You might also be ready to invite some clients to start using your application. At this point, you realize that developing and serving real customers from the same environment is not a good idea. First, you try to make your code more reusable. You refactor a few variables and place them in variables.tf file. At this point, you would create multiple folders in the root of your repository. You might have folders for development, production, staging, QA, and other production environments in different regions. You would also have a folder for global resources such as IAM users, S3 buckets, and Docker repositories that should be global to promote your artifacts between different environments. So far, everything looks straightforward. As your project continues to grow, you add more infrastructure components in the main.tf file or place them as separate files under environment folders. No matter which approach you take, all these components will be stored in the same Terraform state. You'll be able to reference these components, for example, by using AWS VPC to pull VPC ID and use it in different resources. This approach creates implicit graph with dependencies. Terraform will first create VPC, and when it's ready, it will create subnet when VPC ID value is available. There are a couple of issues with this approach. First, if you have hundreds of Terraform resources, it becomes very slow to refresh the state when you run Terraform plan. If you're actively working and testing your infrastructure, you might wait a few minutes for Terraform to refresh the state. Adding more resources will make it even slower. The second issue is that everything is inside the same state file. If something happens to that file, for example, if you accidentally delete or corrupt it by using Terraform remove or import state commands, it becomes a single point of failure. This is not good. In large projects, we start to create subfolders for each component under each environment. For example, you would have a VPC component, subnet component, EKS component, application component, etc. This way, you split your Terraform state into multiple files. In the following tutorial, I'll go into detail and explain all the pitfalls and workarounds. For instance, you won't be able to use Terraform resource references directly. I'll explain a common pattern to address this issue throughout the rest of the tutorial. At this point, you have enough experience and are ready to group some Terraform resources together and create modules. The next approach is monorepo. In the root, you would have environments and modules folders. Each environment would have the same components, but now we create modules. For example, you might have a VPC module, a subnet module, etc. At this point, you simply invoke those modules from environment folders. This approach is simple and works well until you change or upgrade a Terraform module. Since it's just a folder and is referenced in all environments, any change to that module will trigger updates in all your environments simultaneously, which is not what we want. We want to control upgrades for each environment one at a time. To solve this in the monorepo setup, you would simply copy and paste the module and give it a new version. Then you can update anything in that module. When you're ready, you can update the reference to the module in each environment and ensure everything works fine. As your team grows, you decide to start using a more advanced structure. In this case, you create a Git repository for each individual Terraform module. However, you need to be careful because having hundreds of modules would mean creating hundreds of Git repositories. I suggest trying to create reusable modules that you can apply to different applications to minimize the number of Git repositories. Using this approach, you can reference a Terraform module by using a Git repository and Git tag. When you update the Terraform module, you just create a new Git tag and use that tag in your code. We'll go through the evolution step by step. and I'll explain why certain decisions are made. Let's go ahead and create version 1. Each version folder will represent a Git repository for managing your Terraform project. When you're getting started, you will usually have multiple folders for your environments. For example, you might have a development environment. It's typically small and used for development and testing. You will also have a production environment where you deploy customer-facing applications. This environment is usually much larger and more expensive than development and other environments. You could also have a staging environment, a QA environment, or maybe multiple production environments in different regions. For instance, you might have one in United States, another in Canada, Europe, etc. Besides that, you would have some global components as well. This could include IAM users in AWS or frequently global S3 buckets or Docker repositories for all environments. This setup allows you to test and promote the same artifact between different environments. For example, you might build your jar or Docker image and then deploy it to development environment, then maybe staging, and finally to your production environments. So these artifacts are immutable, global, and must be shared across all environments. Let's keep it very simple for the first iteration and define all our infrastructure in a single folder or even a single file. We'll call our first file main.tf. First, we need to initialize Terraform provider. In this video, we'll create a couple of AWS resources such as VPC and a subnet, so you can follow along without any cost. The Terraform project structure we use here will also apply to other cloud platforms. At the very least, we need to specify the region for the AWS Terraform provider. Let's use US East 2. Next, let's say we want to create AWS Virtual Private Network using plain Terraform resources. We'll start using modules later. For now, let's configure a few parameters such as seeder block, DNS support, and the tag. Now, this is bare minimum you need to start using Terraform. Let's go ahead and switch to the development environment folder to initialize Terraform project. This will download AWS Terraform provider and initialize local state since we haven't configured remote state yet. It defaults to local backend and uses terraform.tf state file. Next, let's go ahead and apply configuration. Terraform will refresh the state and ask you if you want to create a VPC in AWS. If you answer yes, Terraform will make necessary API calls to create private network. So far, so good. Once completed, you will be able to see VPC in AWS console. Now, in the Terraform state, we have a single resource with all its attributes. These attributes are very important because we can use them dynamically in other Terraform resources. For example, many Terraform resources require VPC ID. Instead of hardcoding this ID, we can dynamically pull it from the state. Next, you'll typically realize that you want to create the same resources in different environments. To achieve this, you would use variables instead of hardcoding those values. This allows for more flexibility and reusability of your Terraform code across different environments. Terraform doesn't require specific file names, but following some naming conventions can be very helpful, especially when working in a team. For example, for variables, we typically use variables.tf file. This helps keep your project organized and understandable to everyone involved. Let's go ahead and refactor some of our code. First, we'll extract the region variable. We'll create a region variable and set the default to US East 2. This way, you don't need to provide it every time you run plan or apply. And of course, we need to replace hardcoded value with Terraform variable. There are multiple ways to override variables. You can explicitly provide them during execution or use environment variables. This flexibility allows you to customize your Terraform deployments according to different environments and requirements. Next, let's refactor seeder block. You might want to set different seeder blocks for your production environments, especially if you plan to peer them together later. VPC peering requires having different seeder blocks for each VPC. Let's also set a default for now and replace hard-coded seeder block with a variable. This change will make it easier to manage and modify the seeder block settings across different environments. Finally, let's create a variable that will identify our environment. We can call it environment or env. The name doesn't really matter. Now, let's replace the dev prefix with this environment variable. As you can see, we gradually making our Terraform configuration more flexible. Whenever you make any changes or simply refactor, try to frequently run Terraform plan to catch any drift. We should expect no changes and everything looks good for now. This approach ensures that your infrastructure remains consistent with your Terraform configurations. Next, let's follow some additional naming conventions and move provider configuration to its own file. Besides the provider itself, we usually define some constraints for the Terraform and for the provider itself. This can include specifying the required versions of the Terraform and the provider to ensure compatibility and predictability in deployments. Placing these configurations in a separate file, typically named provider.tf, helps keep your Terraform code organized and clear. Let's test one more time and refresh the state by running Terraform plan. By frequently verifying the plan, you maintain a clear understanding of how your changes will affect your environment before making them live. Now, a VPC is certainly not the only component that we would manage using Terraform. You can continue to add more Terraform resources to the main.tf file, or you can create additional files in the same development folder. No matter where you place these configurations, all the information will be still saved in the same Terraform state file. Let's say we want to create a subnet, and obviously we need VPC ID for that. If you have used Terraform before, you know how it works, but let's wait a bit before we start refactoring. For now, let's hardcode the other subnet parameters. The simplest way is to use Terraform resource reference to dynamically pull values from other objects and to build a graph with dependencies. First, we use resource name AWS VPC. Then we use a resource variable, in this case main. Next, we need to find the attribute we want to reference. The easiest way is to Google AWS VPC resource and scroll all the way down. So we're going to use ID attribute. Alright, that's all for the subnet. Besides dynamically pulling VPC ID from AWS resource, we also created implicit graph. Terraform will first apply AWS VPC resource, and when it's ready, it will apply subnet and provide VPC ID value. Let's go ahead and apply it. Alright, let's open Terraform state file. Now we have AWS subnet with dependencies and AWS VPC objects in the Terraform state. When you work on a Terraform project, you can add more resources in the main.tf file, or you can create and host those resources in the separate files within the same folder. This approach lets you use resource references and build dependency graphs. However, there are two major issues with this approach. First, if you have hundreds of Terraform resources in the same state file, it becomes very slow to refresh the state when you run Terraform plan. It may take several minutes, which can be very annoying if your team members are actively working on something. Second, everything is hosted in a single state file. If you accidentally corrupt it, you'll be in trouble. We frequently use Terraform remove or import state commands, and keeping everything in one place creates a single point of failure. To avoid these issues in large projects, we typically create subfolders under environment folders. This helps split Terraform project and, more importantly, Terraform state into multiple components. Before we start refactoring, let me destroy VPC and a subnet. Now, let's go ahead and create a VPC folder. In a real life, you would most likely host everything related to networking in a single folder. This example is just to demonstrate my point. Let's move everything to the VPC folder. Let's also create another component folder for the subnet. In practice, this could be a folder for the EKS cluster, which would also require VPC ID. In the subnet component, let's copy and paste variables.tf file and keep all the variables for now. Just replace CIDR range for the subnet to be a subset of the VPC CIDR range. Next, let's copy providers.tf file as well. You'll soon see that we have to copy and paste some files. If you don't want to do it manually, I suggest watching Terraform tutorial on my channel. We'll keep providers file as it is and won't change anything. Let's go ahead and create main.tf file for the subnet. I'll remove the subnet from the VPC component and paste it into the subnet component. For now, let's keep VPC reference in place. Since we now have two components, we need to apply VPC folder first, then switch to the subnet component and apply it as well. Alright, let me go to the VPC, initialize Terraform, and then apply it. So far, we have created AWS VPC and we have a local terraform.tf state file that describes the objects managed by Terraform. In this file, we'll see only a single resource, AWS VPC. Most importantly, we will need this VPC ID in most of the other components, including subnet. For now, let's switch to the subnet and try to apply it while still using resource reference. Now, you can see the problem created by splitting all those components into different folders. If you have a small project, it's much easier to manage in a single Terraform state file and a single folder. So, how can we solve this? The first solution is to use data blocks specific to the components we need to reference. For example, you can use data AWS VPC and provide parameters to locate this object in AWS. However, you would still need to provide VPC ID. For other resources, you might provide generic names to locate those objects. This approach, as you can see, is not very flexible and doesn't work well with AWS VPC, since we need to provide the ID. Another common pattern is to reference remote state output variables. This pattern is frequently used in large projects. Terraform offers something more flexible, but it's outside the scope of this tutorial. Now, let's comment this out for now, since it's in a broken state. Then let's create Terraform remote state data block. It works with all backends, such as local, S3 buckets, etc. There are just different ways to initialize that data block. In our case, we just use local backend and simply need to specify the path to the state file we want to reference. In this case, we want to reference VPC state file under VPC folder. This way, we'll get access to all attributes from AWS VPC resource. But there is more. For now, let's test and see what variables are exposed from the VPC component. We can create output variable, call it whatever you want, and we'll remove it later. For the value, we need to reference the remote state VPC data block. While we're still in the subnet folder, let's go ahead and apply it. You'll see that there are no attributes available in the test variable. The outputs variable is empty. So let's fix that by exposing variables we need from the VPC component. In the VPC folder, let's create outputs.tf file. Then let's create output variable. Let's call it VPC ID, or you can name it whatever you want. The value will be a reference to the AWS VPC Terraform resource. First, reference AWS VPC, then main variable, and finally ID attribute. Alright, we have output variable, but we still need to run Terraform apply to register that output to the Terraform state. We need to do this in the VPC folder first. Now, you can see we have VPC ID output variable. Next, let's switch to the subnet folder and run apply as well to see our test output variable. Finally, we have VPC ID variable that we can reference in the subnet component. This could also be referenced in a Lambda or EKS component. Now, we can uncomment the subnet and provide VPC ID from the different Terraform state file. After VPC, we have outputs and finally VPC ID variable. We no longer need test output, so we can remove it. This is a very common pattern for referencing other components in your Terraform project. In Terragrant, you can use dependency. Let's apply Terraform and see if we can create subnet. Alright, now we have AWS VPC and the private subnet. We can slightly refactor this code to use it in other environments, such as production. We can use a seeder variable and env variable for the name tag. Also, we frequently place data blocks in data.tf files. If you follow the same naming conventions, it will be easier for your teammates to locate necessary objects quickly. Usually, many people in the company work on a Terraform project, so it's not just you creating all the components. Let's run plan to make sure everything is up to date. As you can see, by splitting project into multiple components, you only need to refresh a subset of your infrastructure each time you run plan. Alright, but now we have a problem. We don't have a dependency graph, so we need to create and destroy Terraform infrastructure in the same order. Let's go ahead and destroy AWS subnet first. Then we need to switch to the VPC and destroy it as well. When you split Terraform into multiple components, you need to create some kind of higher abstraction layer, unless you use Terragrant. This could be a simple bash script that applies one component at a time, or you could integrate it into your CI/CD pipeline. For example, you might have a GitHub action step for the VPC component, followed by the step to apply subnet, etc. For simplicity, let me create a very simple bash script to show the idea. Let's put it under dev folder for now, and you can name it tf.sh. First, let's create apply function that goes to each component and applies Terraform. Then we could have a destroy function that in reverse order destroys those components. Based on the bash argument, we either apply or destroy. In real life, this is going to be much more complicated, of course. Let's go up to the development folder and make our script executable first. Then let's run tf apply to create both VPC and subnet. Now we have both AWS VPC and private subnet. We can destroy infrastructure using tf-destroy command. That's the basic idea. Create a script or integrate it into your pipeline. Let me copy and paste the same setup into the production environment. You can update some environment variables. Maybe you want to use a different seeder block or deploy to a different region, which is a common for different production environments. Let me update the same variable in the subnet as well. Alright, this is the first version when you're just getting started and not using Terraform modules yet. There is nothing wrong with this approach. It involves a lot of copy pasting, but it makes day 2 operations easier when you update your existing infrastructure. Now, let's say you have been using Terraform for a while and you are ready to move to a more advanced structure. Let's go ahead and create v2 folder that will represent a single Git repository. In that folder, you would create a subfolder like envs or maybe even environments. Some people call it infrastructure live or just live environments, etc. We'll also create another subfolder for the modules. This is the monorepo approach, and we'll go over the benefits and drawbacks of this approach. You might not even need to move to more advanced structure. A Terraform module is just a bunch of Terraform files and resources grouped together and placed in the same folder. Let's create the same development, production, and global environments. Next, let's create a VPC module by simply copying and pasting the VPC folder. We'll make some changes to follow best practices when it comes to modules. First of all, we never initialize Terraform provider inside the module. We do it from the live environments folder. Let's rename providers to versions.tf file, as this is one of the naming conventions in the Terraform community. Next, create a VPC folder under dev environment. We also need variables, for example, to use for the region when initializing AWS provider. Finally, let's create main.tf file for the VPC itself. First, we need to initialize AWS provider. Then we call our VPC module. I like this Terraform structure because you can work and update both modules and environments from the same place. If you have a small team or a single DevOps person in the company, I suggest sticking with this approach as it's easier to manage. Next, we can provide some variables like environment and seeder block. Next, let's create another module for the subnet. But before that, let's create VPC using this more advanced approach. Let's initialize and apply Terraform. So far, we have created VPC using new approach with a monorepo. Next, let's copy and paste the subnet files into the subnet module. First of all, we don't need the data block inside the module, so let's remove it. Then let's remove provider and rename the file to versions.tf as well. Next, let's refactor VPC ID variable. Instead of using data resource inside the module, we'll provide VPC ID as input variable to the module. Let's call it VPC ID and set no default value for it. inside the resource, we'll use that variable. Next, we need to create a similar structure. Let's create a new subnet folder in the dev environment. Let's also create a variables.tf file with the region for the AWS provider. Then create a main.tf file and initialize provider. Next, we can call subnet module. However, we have a problem. We need to provide VPC ID. You might think that since we have output variable in VPC module, we can use it right away. Well, let's test it. For now, let's comment out the subnet module and define data block and test output variables. It's essentially the same thing. Switch to the subnet live folder, initialize and apply Terraform. And here you can see that we actually don't have any output variables. We use outputs in the module, but we have never registered them in the state file. In other words, if you create subnet in the same folder as the VPC module, you can use VPC module as an input variable. However, if they located in different folders, it's not going to work. To fix this, we need to create output variable inside live VPC folder. Let's call it outputs.tf. For the value, we'll use module output variable. Alright, now we need to go back to VPC and apply it. Next, let's switch to the subnet and test it again. Alright, now we have VPC ID attribute. Let's remove the test variable and use data attribute as input to our subnet module. Let's initialize and apply it again. Alright, now it works. We have created VPC and subnet using modules and a monorepo. Now we can pretty much copy these components to all other environments and maybe change dev to prod. I like this approach because it's simple, but it has a significant drawback. Occasionally, we need to change something in the module. For example, there might be a new feature in AWS and you need to upgrade AWS provider and use that feature inside Terraform code. There is a problem because our modules are just folders. If you change anything in the module, it will trigger updates in all other environments. If you have 5, 10 or even more production environments, you'll want to update them one by one, and it's unlikely you can do it all in one day. So you need a way to version your modules. In a monorepo setup, this is often done by simply copying and pasting. For example, let's copy VPC module and create a new v2 version. It's totally fine to copy and paste using this particular intermediate approach. Now, in this version, let's say we want to refactor DNS support and use variables instead of hardcoding them. Let's create new variables and refactor Terraform code. Now that we have a new version of our module, we simply update the reference in each environment one by one and test that Terraform code only makes the changes we intended. First, we need to initialize because we're using a new module. Then apply it and verify that only DNS support is changed. If it looks good, we can apply the changes. After that, you can go ahead and update the module in other environments. This would be intermediate approach to structuring a Terraform project. Now, it's time for the most advanced approach. Let's go ahead and create a v3 folder. In this repository, we'll also create a live environments folder. Let's use the same development, production, and global environments. The biggest difference compared to the previous approach is that we'll put each Terraform module in its own Git repository. So let's go ahead and create a new repository for the Terraform VPC module. We typically use the following naming convention for the Terraform modules: Terraform prefix, then provider, and the component. Let's keep it private and add a README file. Next, let's clone this repository. Open it in a text editor and copy-paste the VPC module from the previous example. Let's keep it as is for now and commit all the files. The biggest benefit of this approach is being able to use Git tags and version control for your modules. For this version, let's set 0.1.0 git tag. You can reference branches like main, dev, etc., but the preferred way is to reference git tags. Let's go ahead and push everything, including tags, to the remote repo. Now we have the source code in GitHub and we have git tag that we can reference. Next, let's create the same structure and create a VPC folder. Copy and paste the same files from v2 version. The difference is that instead of referencing the local path with the module, we'll reference the Git repo and the Git tag. Let's go ahead and apply it. You can see it uses GitHub repository. Now, let's say we want to make the same changes as in the previous example and release a new version of this module. Let's refactor the same variables out. To release a new version, we will commit all the files and create a new 0.1.1 git tag that we can reference. Now we have a new tag. Let's go ahead and upgrade it in dev environment. For that, we simply change the git tag. While this looks like a better approach, it can quickly become overwhelming. If you have hundreds of modules, you would need to create hundreds of git repositories. If you have a small team or a single person managing infrastructure, switching between different repositories can become cumbersome. Based on my experience, if you decide to use this approach, try to create reusable modules for deploying your applications. For example, your app may have the same autoscaling group, network load balancer, and other components. Instead of creating a Terraform module for each microservice, try to leverage the same module and make it flexible enough to deploy multiple applications. Version v2 is not as bad as you might think, just because you need to copy and paste modules. It's much easier to manage. Thank you for watching, and I'll see you in the next video.